Open your task manager right now. Looks normal? That actually doesn't mean much. Because most hacked computers don't look hacked. No pop-ups, no crashes, nothing screaming for attention. They just run quietly while something else is happening underneath. There's a reason for that, and it's going to change how you look at your own PC. If you want to follow along on your own PC as we go, the tools we're using today are all free, all made by Microsoft. Subscribe to Tech Reporter now so you don't lose this when we go deeper into each one. So let's talk about the actual signs. But before we get into that, there's one thing you need to understand first, or none of the signs are going to make sense. Here's the thing almost everyone gets wrong. If my computer is infected, my antivirus will catch it. Sometimes that's true, often it isn't. Modern malware is built specifically to avoid detection. It borrows the names of real Windows processes. It hides inside legitimate system tools instead of running as something obviously foreign. Some strains even monitor whether Task Manager is open and throttle themselves the second you go looking, only to ramp back up once you've stopped watching. This isn't a flaw in your antivirus. It's a deliberate design choice by the people writing the malware. They know what you're going to check, so they built around it. Which means the real question isn't, is something flagged as malicious? It's, is something behaving like it shouldn't? And that distinction changes everything about how you need to look at your own machine. Signal 1. Performance that doesn't match your usage. Start with the simplest tell. Your computer working hard when you're not asking it to. Not during a render, not during a game, during nothing. You open a browser tab and the fan spins up like you're running a flight simulator. Your laptop runs hot sitting idle on a desk. Programs that used to launch instantly now take a noticeable beat. On its own, this could be a software update, a background sync, an outdated driver. That's exactly why most people dismiss it. But persistent, unexplained resource usage, CPU, memory, or disk activity that has no relationship to what you're actually doing, is one of the most consistent indicators that something else has taken up residence on your system. The fix isn't to assume, it's to check. Open Task Manager, sort by CPU and by disk, and watch what's consuming resources when you are doing, deliberately, nothing. But here's what most guides won't tell you. The process responsible might not even have a suspicious name. Signal 2. Legitimate-looking processes behaving strangely. Windows has core processes that are supposed to use resources. svchost.exe, for example, is a real system file that legitimately hosts background services. That's exactly why attackers love it. A process injection technique lets malicious code run inside that trusted process instead of creating a new one with an obviously fake name. So you look at Task Manager, you see host process for Windows services, and you move on. Nothing to see. Except now there might be a second or third instance of that exact process running, each one quietly doing something the others aren't. This is the part that should genuinely concern you. A clean-looking process list is not the same as a clean system. The name on the label tells you what the process is pretending to be, not what it's actually doing. There's a tool, free, built by Microsoft, that exposes exactly that gap, and it takes about 30 seconds to use. Signal 3. Where your computer is talking to, without you. Every process on your system that touches the internet has to connect somewhere. That connection has a destination, an IP address. And that address tells a story your antivirus might miss entirely. This is the part most users never check, because it requires almost no technical skill, just the right window open. A tool called TCPView, part of Microsoft's own sysinternal suite, lists every active connection your computer is making in real time, along with which process made it. Most of what you'll see is boring. Your browser talking to Google, Steam talking to Steam servers, background telemetry you've already agreed to. That's the noise. What you're looking for is the signal underneath it, a process you don't recognize, or one you do recognize behaving in a way it shouldn't, connecting to an address you've never heard of, especially while you're doing nothing that should require a connection at all. Close everything you know is supposed to be running. Steam, Discord, your browser, anything with legitimate reason to phone home. Then look at what's left. If a process is still reaching out to the internet with nothing open that would explain it, that's no longer a coincidence. That's a lead. And the address it's reaching out to can tell you more than you'd expect, including, sometimes, exactly which country the attacker is operating from. Signal 4. Remote control you didn't ask for. There's a category of compromise that's harder to rationalize away than a slow fan or a strange connection. Your computer doing something while your hands are nowhere near it. Your cursor drifts. A window opens on its own. Settings change without your input. This is one of the more direct signs of compromise there is, because it strips away every benign explanation. It's not an update, it's not a background process, it's not your imagination. Someone, or something, has remote control of your machine, and they're using it. By the time this happens, the earlier signals were almost certainly already present. They were just quieter and easier to ignore. Ignore the quiet signals long enough, and this is where they lead. Signal 5. Accounts and logins that don't belong to you. Not every compromise stays on the machine. Sometimes the most important sign isn't on your computer at all. It's in your inbox. Login alerts from unfamiliar locations. Password reset emails you didn't request. Friends receiving messages from your accounts that you never sent. These are signs that credentials stored or typed on a compromised machine have already made their way out, which means the timeline for fixing this just got shorter. This is also the point where the conversation moves past, "Is my PC infected?" and into, "What has already been taken?" Because malware that sits quietly and watches doesn't need to break anything to do damage. It just needs time. Here's the part that should reframe everything you just heard. The malware landscape has shifted. Attackers increasingly use the same legitimate enterprise tools IT departments rely on, specifically because security software is built to trust them. Vendors and major platforms have been compromised, not through some dramatic breach of their own defenses, but through smaller, less protected third parties they relied on, proving that even careful systems inherit the risk of everything connected to them. Your home computer is no different. Every browser extension, every piece of software with update permissions, every account you've logged into is a thread connecting your machine to something else's security, or lack of it. This is why "my antivirus didn't flag anything" has stopped being reassuring. It was never designed to catch behavior. It was designed to catch known signatures. And the entire economy of modern cybercrime exists specifically to stay one step ahead of that list. Which means the responsibility for catching this has quietly shifted from your software to you. So here's the sequence, in order. Check resource usage while idle, and don't dismiss what doesn't add up. Open your process list and look past the names. A legitimate label doesn't guarantee legitimate behavior. Check your active network connections, close everything you recognize, and scrutinize whatever's still talking to the internet. Take any unfamiliar process or address and look it up before deciding it's nothing. And if you find anything that confirms a compromise, isolate it, document the IP addresses involved, and report them, because the infrastructure attackers rely on can often be shut down by the very providers hosting it. None of this requires paid software. None of it requires being an expert. It requires 15 minutes and the willingness to actually look, instead of assuming silence means safety. And if this video changed how you'll check your own PC tonight, subscribe, because we're going deeper into exactly this kind of investigation every week. Stay informed, stay secure.